Our lesson today is about fractional expressions, and precisely literal fractional expressions. We will learn how to find the condition of existence, how to simplify, and how to do operations. First, a literal fractional expression is a fraction that contains letters or variables in addition to numbers. For example, first one, we have x, a letter, it's the variable in this fraction, or the second one, a, b, and c, and d are the variables. Now, how to find the condition of existence, or how to answer the question when this fraction is defined. So the fraction is defined, a literal fraction is defined if the denominator is different than 0. If the denominator is equal to 0, the fraction won't be defined. So the fraction exists only if the denominator is not equal to 0. Like in the first example, the denominator x minus 1 must be different than 0, so x must be different than 1. The other one here, m power 2 minus 9 must be different than 0, so m must be different than 3, and also m must be different than minus 3, because if m is equal to one of these two values, the fraction won't be defined, because we will have 0 in the denominator. We cannot divide by 0. Here we have some examples about questions. So if you get some of these questions or one of these questions, here how to answer this question. For example, the first one, for which values of x does f of x exist? The answer must be f of x exists for x minus 1 different than 0 and x minus 4 different than 0, and we continue. Why? Because here in the denominator we have a product of factors, two factors. If one of them is 0, so the fraction won't be defined. Therefore, the two factors must be both different than 0. So we write it in this way. The second type of questions, for example, determine for which values of x is f of x defined. Okay, so f of x exists, same meaning as f of x is defined. Here we answer like this: f of x is defined for x minus 1 different than 0 and x minus 4 different than 0, and we continue. Third type of questions, determine the conditions of existence of f of x. Also, same idea, f of x exists if, etc. Now here the fourth type, determine the domain of definition. When we say domain of definition, means that we are asked to find all the values of x so that f of x is defined. Here we have only two numbers that make a problem. Okay, so x must not be equal to 1 or 4. Then x can be any other number. So x can be any real number, or x belongs to R except 1 and 4. X could be any real number except 1 and 4. So we write it in this way: domain of definition equal all real numbers are minus except 1 and 4. In this way, it's like we say that the fraction is defined for x different than 1 and x different than 4. The same idea. How to simplify? To simplify a literal fractional expression, first we must find the condition of existence. Then we factorize both terms, numerator and denominator, if possible, if we can factorize. Then we cancel the common factors. For example, here we have a fraction. Condition of existence, the denominator must be different than 0. So m here in this case must be different than 1 and different than minus 1. After factorization, the numerator is equal to m minus 1 all to the power 2. Denominator m minus 1 into m plus 1. We cancel the similar terms, so we'll get m minus 1 over m plus 1. Now how to add two fractions? First, like always, we find the condition of existence, then we simplify, then we find the same denominator, and we add or subtract. Um, Now, if we want to multiply, also first we find the condition, then we multiply numerator by numerator and denominator by denominator. Then we simplify. Of course, sometimes we need to factorize first before simplification. When we have a division between two fractions, we transform it into a multiplication by writing the first fraction, then instead of divide, we put times, then we write the reciprocal of the second. We'll do some examples. In the first application, here, we have three fractions. Here we notice that the first denominator could be factorized. Okay, so it's very easy to factorize x power 2 minus 9. It will be equal to x minus 3 into x plus 3. Please try always to factorize if it's possible before finding the condition. It will be very easy. So after factorization, we will notice here that we have x minus 3 two times and x plus 3 also two times. We don't need two factors. So we take in the condition only one of them. We take x minus 3 one time and x plus 3 only one time. So this fraction or these fractions are defined if x minus 3 is different than 0 and x plus 3 is different than 0. So the condition is x different than 3 and x different than minus 3. Now we will find the same denominator. It's very easy and you already know that. And then we add and subtract. Now here we have division. First we transform division into multiplication and we write here the reciprocal of this fraction. Reciprocal of 8 over x2 minus 16 is x2 minus 16 over 8. After that, we will notice here in the denominator we have x minus 4. So x minus 4 must be different than 0, x different than 4. Of course, 8 is always different than 0. Okay, so we don't need to write it. Then we multiply numerator by numerator, and here we can factorize x power 2 minus 16. It will be equal to x minus 4 into x plus 4. And we will have one common factor. We can simplify, and we will have also 2 and 8. We can divide by 2, both of them. So the final answer will be here. Please study well and do your homework.